Hello, everybody. It's time again for Astro Coffee Hangout. My name is Tony Darnell from deepastronomy.space. And wow, boy, I hope it's a good thing we do this virtually, isn't it? I mean, now we live, all these major conferences are getting canceled. I mean, they even canceled South by Southwest. I can't believe that because of the COVID stuff. NEAF has been canceled for amateur astronomers out there. Well, hasn't been canceled so much as I think they're just planning on doing it remotely or somehow virtually. But we don't have to worry about that because Astro Coffee is virtual every Thursday. So today we're going to be virtually talking about this new report that came out from the European Southern Observatory on the astronomical ground-based observatory effects of the Starlink satellite constellations and others like it. Now, if you don't know, I'll do a brief summary of what that problem is here in just a minute. But before I get going too much, I want to say hi, everybody. Peter Q's here, and Brian, it's good to see you. Raj, and I think John Suffel, there he is, and Hans Milling, and Alberto from Exoplanets channel. It's good to see you, too. So welcome, guys. It's good to... Asteroid Mike's here. Good. Hi, Mike. So sometimes I can get guests, sometimes I can't. This is a busy time. Astronomers are very busy people, and sometimes wrangling them is a difficult thing to do. You guys can appreciate just how much Harley and Carol contributed to these hangouts when you saw that every week we had somebody here to talk to and lined up, usually one of their colleagues. I don't have that kind of clout, so I have to kind of wait until people want to be on a hangout and talk to us. So I don't always have guests for each one of these, but I still want to stream. I still want to connect with you guys. And this is a topic, and I want to do it about topics that we're all thinking about at the time and ones that I haven't made a video about as well. So that's what we're doing here, and several ways you can interact. You're already doing it on the live chat, which is great. And I also have a Discord server. The link to that is in the description box. You can certainly join that as well. And if anybody clicks into the voice channel on there, then I will also patch you in if you want to say something with audio, and so we can try that as well. Okay, so let me set up the situation here. We've always had satellites over our heads since Sputnik, right? I mean, that was the very first one. We've always had various amounts of things flying over our heads at various altitudes, and it has not been such a great problem for ground-based observatories because they're not always up and in the way of the observations that they're trying to make. Well, times are changing with respect to how many satellites are up there. The biggest change is coming from SpaceX and Elon Musk. They want to create and are creating a constellation of satellites that will be launched in Earth orbit about I think it's about 500 kilometers up, at least at first. So right now, as of the 1st of March, they have 300 Starlink satellites, and these are going to be eventually a blanket of satellites that cover the globe, providing hopefully low latency, high speed internet for anybody on the planet. And that's a pretty good goal. And it's one I actually support. I think that it would go a long way to making internet available to those who simply can't get it. And it would also provide a second choice for most of Americans who only really have one choice, because the cable companies and the internet providers here in our country have colluded to split up the markets so that only one provider, or maybe two, exists in any given area of the country. So this will provide, no matter where you are, a second choice, at least, maybe a third, probably not more than that. So I support what SpaceX is trying to do and what the goal is of providing internet. We don't know what it'll cost yet, although I'm hearing words about $60 a month, and it's supposed to have gigabit speeds with latencies in the orders of tens of milliseconds, which, if they can pull all that off, will be amazing. So, but setting all of that aside for a moment, one of the things that became quite concerning was the sheer numbers of satellites that they're going to launch. So as I said, as of March 1st, they've got about 302 satellites, but their goal is to launch 60 more every single time they launch a Falcon 9, okay? And that could be as often as every 2 weeks. And they've already gotten approval for, I think, 1,200 from the FCC, which I'll come back to that in a minute. But ask yourself this: why is the FCC in charge of our night sky, but we'll go back to that in a minute. Anyway, they ultimately want to get permission for 12,000 Starlink satellites that will go up, and with the final plan of maybe going as high as 42,000 satellites overhead. Now, they're not the only company wanting to do this. Everybody else has things they want to do. Jeff Bezos and other billionaires want to also clog up our night sky. So astronomers are starting to ask the question, well, wait a minute, what is this going to mean for our observations? And so we don't really know what effect that's going to be. So companies are the European Space Agency, as well as, I should say, the American Astronomical Society is working on a study too, but the European Space Agency, the European Southern Observatory, just last week announced published their study that that came out. Oops. Sorry, I hit the wrong button on my keyboard. There we go. ESO, the European Southern Observatory, is a scientific institution that's based in Germany, but they're a European collaboration that operate telescopes in the Paranal site in the Andes Mountains in Chile, and they studied the effect of these satellites on their ground-based observations. And so we need to kind of define the problem a little bit. And to do that, now I put a link to this press release as well as a link to this paper, the study itself. So both of these are in the link, so you can read along yourself if you want to. But I'm just going to read you the introduction because this is really, it outlines the problem really well and what they're trying to solve. So here's just a few words from the introduction. While artificial satellites have until now been a substantial concern for radio astronomy and a relatively minor issue for observers in the optical spectrum, the recent launches of the SpaceX Starlink constellation with their spectacularly bright post-launch appearance and the growing publicity of the plans of other companies from major constellations of thousands of satellites have caused alarm in the astronomy community. The issue has also generated substantial media attention, which has highlighted the emotional and moral dimensions of the issue that go beyond the impacts on astronomical science. In order for the astronomical community to respond to these developments and work constructively with industry, funding agencies and regulators, a factual and quantitative assessment of the impacts is required. This paper aims at quantifying the effect of large satellite constellations on visible, near-infrared, and thermal IR astronomical observations using a series of simplifying assumptions. It does not replace careful, detailed simulation taking into account the intricacies of the orbital distribution, the complexity of estimating the brightness of a satellite, and so on, but provides a first quantitative estimate of the effect. As the simplifications and the assumptions are conservative, and the estimated effect is likely greater than the actual effect. Okay, so they start by talking about all the different ones they're taking into account, and they're assuming that there is a constellation up there of about 26,000 satellites. This will include everything from what SpaceX is doing to what Blue Origin is trying to do. I forgot the name of theirs. Anyway, the ones that are Blue Origin, and there's other companies that want to do, but they take up to 26,000 satellites into account in this thing. Now, one of the things I want to show you that started all of this was this image right here. This image, it's not really fair to SpaceX, but this is what started a lot of the hubbub, right? This was an image that was taken it's of a group of galaxies, NGC 5353 and 5354, made at the Lowell Observatory in Arizona. And this was taken on 25th of May, 2019, just after a launch. And even the caption is telling here. It's, although this image serves as an illustration of the impact of reflections from satellite constellations, please note that the density of these satellites is significantly higher in the days after launch. And also that the satellites will diminish in brightness as they reach their final orbital altitude. So that's why this isn't fair to SpaceX. They had only just launched. These trails, these diagonal lines, are all satellites flying through an exposure that was being made at Lowell Observatory. And they were getting to their final orbital places, and they were all bunched up. So this is not the final resting place of where these things are going to go. So, but this was alarming to a lot of astronomers, and they got to thinking about this. So, that was one of the reasons why this kind of thing got started. So anyway, I'm gonna look. I'm not looking at the chat on purpose because it distracts me, and I'm gonna look at it as soon as I finish my little spiel, which ought to be in just maybe 10 minutes most. So we'll talk about this in just a bit, but I want to lay out the problem first, and then we can chat more. So please forgive me for not checking the chat out, because I get distracted and I go off on a tangent. So getting back to the paper. The first thing, what you have to remember is while there may be 26,000 satellites in orbit, not all of them are going to be relevant and in the way while you're doing an astronomical observation. So the first thing that this study did was it looked at the number of constellations that would be in range. And this is interesting because if you look at this part right here, we now estimate that the number of satellites above the horizon of an observatory, which is zenith is 90 degrees, it's straight overhead, and about 60 degrees, which is a little bit further down, than above the horizon, then that corresponds to an air mass of about 2. Now that is where most of the astronomical observations are done. They're done in an area of sky that's almost straight overhead, okay? Because they want to look at as little air as possible. So what is an air mass? Let's get to that first. If you look straight overhead, when it's an astronomical term, there's several kinds of air masses. We're not talking about the weather meteorological one. We're talking about the one that applies to astronomy. An air mass is a measure of how much air you're looking through. And as you can imagine, you want a clear as image as possible with no scintillation and no atmospheric distortion. So you want to look through as small an area of the air as possible. And of course, that's straight overhead, right? That corresponds to an air mass of 1. You can have an air mass of less than 1 if you happen to be at a very, very high altitude. But this is assuming that we're looking at air masses between about 1 and 2. So air masses can go all the way from 1 at the bottom, and all the way down to, what's the number? All the way down to about 38 at the horizon. So as you look further down lower, you're looking through an air mass of about 38. So almost all astronomical observations, because we want them to be as high quality as possible, happen in a cone of sky over our head between air mass 1 and 2, which corresponds to about 90 degrees over our heads to about 60 degrees over the horizon. Okay, that's where most astronomical observations are taken. Anything lower than that is not going to really affect a typical astronomical observation. So what this study then did was, okay, let's look at that area of the sky and let's see what effect that's going to have. How many would be up at any given time when we're trying to observe? But it's even a little bit more complicated than that, because these satellites really only get in the way when you could take an image, they're really only getting in the way when the sun is shining on them, right? This is for optical and infrared. We're not talking about radio. So when the sun is shining on the satellite and reflecting light down into the telescope, that's when it becomes a problem. That's what these trails were all about that I showed you a while ago. Those were reflections of the satellite from light shining on the sun. So the geometry of that looks like this. Let me see if I can show you that. Yeah. So here is a schematic of when a satellite would get in the way. Here's the observatory. Zenith is straight overhead. I hope you can see yeah, you can. Zenith is straight overhead, okay? And here would be a satellite, okay? This red dot right here. And down here would be towards where the sun is. So the sun will be shining its light somewhere below the horizon because it's set. We want to do these observations in the dark. So the sun is below the horizon. The sun, however, because of the geometry, is shining light on a nearby satellite. So when does this happen? Primarily at dawn and primarily at dusk, okay? The middle of the night, the sun is well behind the Earth, not shining light on any of these satellites, and so it doesn't become a big issue. So I hope I'm helping you understand and picture what the problem is and the geometry of the issue. Okay, so not just because there's 26,000 satellites up there isn't going to be a problem. It's going to be how many are going to be up there when we are looking. So let me scroll up here to this table. So they did all of that analysis and they did all that counting. They produced this table here where they just said, okay, look, they included SpaceX Starlink, OneWeb, Kuiper, Amazon Kuiper, and then all these Chinese and Indian and I didn't know that Samsung was planning on putting in 4,700 satellites. Wow, that's a lot. I didn't know that. And Boeing is planning on doing 3,000. Some of these, I think the paper acknowledges aren't happening. They've been canceled. But a lot of these I didn't know about. Like, Iridium satellites, I think we're all pretty famous because a lot of us like to look for Iridium flashes. It's a thing you can predict. There's only 66 of those. But look at all these other ones. Amazon Kuiper is looking at putting in, a couple thousand of these things. And so SpaceX Starlink is the big one, though, to do the most. 14,000 or up to 26,750 satellites. How many of these are above the horizon at any given time? This depends on their orbits and their altitudes, obviously, and there's a big discussion on that in here. I'm not going to go into it. But there's going to be 1,605 satellites up at any given time. But how many of those are going to be in the range that astronomical observatories are looking, like 60 degrees? Well, according to this, around 258. Okay, so of the 26,750 total satellites, 258 are going to get in the way, which sucks, and that's because of this geometry right here. But so that's I should also mention that these are going to be on a. Well, let me show you this first. So here's an image that ESO put out in its press release. That is sorry, my computer is now somehow really straining on this. This is a graphic or an illustration of the sky above Paranal in Chile. Okay, the blue lines are different altitudes above the horizon. You can see that bright blue in there is 30 degrees, and the hang on just a quick sec. So the vast majority of the satellites that are up are going to be below that blue line, which really isn't a big deal. Only a few of the satellites, which are marked in red. I hope you can see this. It's hard to see. It was hard to see even in the blown up image on my laptop. So I don't think it's coming through on the screen. So you might, or in the stream. So you might want to go look at this image yourself on your computer. But you can see that the green, those green circles all around the perimeter of the image. That's where the satellites that would be above the 30 degrees, but not really or below the 30 degrees altitude, but not a problem, would be. And there are some red circles in there as well. Okay, and these red circles will be a problem. They're in the middle there, and you kind of really have to zoom this up. Let me see if I can zoom it up without my computer like going completely nuts. Oh, okay. Yeah, here we go. So here's a zoomed up version. You can see the red dots in there along with some green dots. I don't know why the green dots are green. in the middle of the observing area. But anyway, these red dots are the problem ones, okay? And there's not that many in there. Now, these are going to be relatively bright. They're going to be about a magnitude of 3 to 4, okay? So this is pretty bright. It may not be bright to your naked eye, but it's going to be bright to telescopes that are designed to look at magnitude 20 galaxies, right? So for comparison, the North Star is a magnitude of 2. Okay, that's how bright the North Star is, Polaris, and that is 2.5 times brighter than an object of magnitude 3. So that is a way of, because the magnitude scale is logarithmic in a factor of 2.5. It's weird how much, it's not a linear progression of something being magnitude 2 being twice as bright as magnitude 3 or something like that. It's not like that. So a magnitude 3 object would be 2.5 times brighter than a magnitude 3 object. And that's another thing that's confusing about the magnitude scale. The bigger the number, the dimmer it is. So a magnitude 10 is way dim. You can't even see it with your naked eye. But and it goes negative. I think Vega is minus, what's Vega? Vega's like minus, is it minus 3? I forget what it is. You guys would know what it is. So anyway, this is what a typical night observing would be like. And how many of these would be up. So that's may not sound so bad. Okay, I mean there weren't a lot of green and red circles in that image I just showed you. So okay, what's the big deal? Okay, well let's go to the part of the study where they talked about. All right, so let me just go down to the part of the study where they talked about, this is the magnitudes, the brightnesses, and all of that kind of fun stuff, and the different kinds of contamination that you can get. One of them would be specular flares. One could be thermal infrared emission. Okay, so here is where they talk about what kind of observations would get contaminated. Okay, and they talk about the effect of their instruments in particular, standard imaging in the visible. Individual exposures range from a few seconds to a couple of minutes. It talks about the kinds of observations that each of those instruments take. But here's the part I want to show you. Here's their conclusions on what is affected and how. It's called Contamination of Observations in the Visible and Near Infrared by Satellite Trails. The effect of satellite trails is different for the different types of exposures being considered. It makes sense, doesn't it, that this is dependent on the exposure time. The longer you're exposing, the more likely it is something's going to fly across your field of view and contaminate the image. So short exposures of about a second are essentially not affected by the satellite trails. Medium duration exposures of about 100 seconds are affected at a very low level, they say about 0.1% during the night, and at a low level, about 0.5% during nautical twilight. Remember, twilight and dusk are the times when the sun is going to be the most reflective on these satellites. And long spectroscopic observations of about 1,000 seconds are affected at less than 1% level during the first and last couple of hours of the night. So again, when you do these matters. And at the 1% level during astronomical twilight. This can, in most cases, be mitigated by not scheduling long exposures during the astronomical twilights. Okay, so that's easier said than done. I suppose you want to do that to some extent anyway if you're looking at really long exposures and you want to get rid of the sky gradients. But here's the thing that's going to get hit by Starlink satellite constellations. LSST wide field exposures on a large telescope, up to, listen to this, up to 30% of the exposures would be lost during the first and last hours of the night. I'm reading this part right here. And almost 50% of the twilight exposures would be contaminated. 50% of your twilight exposures would be useless. The combination of wide field, well, it wouldn't be useless, it would just be contaminated. The combination of wide field of view and the huge collecting area of a large mirror makes this type of observation very sensitive to satellites. This is likely to cause significant disruption in the scheduling and efficiency of the surveys. Now, so this primarily talks about wide field surveys. Okay, these are projects like the Sloan Digital Sky Survey, the Dark Energy Survey. There's been others that look at big chunks of the sky over and over and over again for many, many nights. Now, LSST in particular wants to take images of the entire sky 2 or 3 times a week. It wants to look at the entire sky several times per week in high resolution. And so that is most definitely going to be affected by the Starlink satellites. So this is kind of a wake-up call. I mean, imagine if you were working on LSST or some kind of survey similar to it, and you go through all this work to plan it out, and then suddenly find out that without anything you've done, no matter what kind of processing you've done, what kind of work you've done, analysis to build and design this thing, it's all doesn't matter. Because 30 to 50% of your exposures are going to be contaminated by sources outside your control way before you even take a single image. Now, this, of course, is granted it's toward the beginning and the end of the evening, but still, that's a lot of damage. And that is what the survey or this report is characterized as surveys being severely affected by these satellites. So what can we do about it? Well, so there's a section on mitigation, and then I'll stop. So what can we do about it? 2 main types of mitigation can be considered. I'm reading again from the survey or from the report. The first is scheduling of observations. Now, that by itself is not very easy it's easier said than done. These things are in high demand, especially the programmatic telescopes like Keck and the ones at VLT and the ones at Parnell. Those are all very much high in demand telescopes. So just to say I'm going to reschedule it, okay, sure, fine, that's expensive stuff. Now I've got to wait. I was already waiting a year to get my telescope time. Now I'm waiting either some number greater than that because we're having to reschedule around dawn and dusk. Okay, so that's easier said than done, and it's also quite expensive. And should the astronomical community pay that price? So at the global level, observing toward the direction opposite of the sun, toward the east in the evening and toward the west in the morning, will ensure that the satellites are in the shadow of the Earth. That's another, so you can just avoid those areas where the sun is. Therefore avoiding contamination of the exposures. While this is simple to implement and will work even for a wide field of view, this mitigation method is not suitable for all programs. At a much more detailed level, it is possible to forecast the position of the satellites from their orbital elements and to observe a field at a time when it will not be crossed by a satellite. So that's some kind of complicated dance between knowing the orbital element of 26,000 satellites and then figuring out your observations of when you can dance around when it's going to be there. I mean, that's certainly possible, and it's doable, and it's probably what most people will implement. The implementation, however, of this mitigation is much more complex and is not suitable for all programs. For example, it may turn out to be impossible to schedule a long exposure with a wide field of view. You just might not be able to do it. Now, the second type of mitigation involves interruption of the observations themselves. For programs that require observations in the region of sky where the satellites are illuminated, it is possible to compute the exact time when a satellite will cross the field of view and close the shutter during that time. The implementation of that mitigation would be complex, and it is not suitable for all programs. For example, a large field of view would require so many interruptions that the exposure would not be practical. You couldn't get it in one night. In both cases, the availability of high-precision, up-to-date orbital elements of all the satellites would be crucial so that the accurate position of the timing of the satellites can be computed. And so ends So there you go. That's their report. That's the highlights of their report. There's a lot of details in there on how they did what they did, and I encourage you to read that stuff yourself to get a better idea. But to recap, it looks like about 4 to 7%. Let me go back to that part. 4 to 7% of some observations, like wide field imaging. Let me just so there was this thing on wide field imaging with Omega Cam and multi-fiber optic spectrographs like Foremost are affected at the 5 to 7% level at the beginning and the end of the night. See, this is already problematic, isn't it? Because we spend a lot of time building these observatories in dark sky locations free of light pollution, and now we've got another kind of pollution to deal with in the early evening and the late evening and the early morning. So these are contamination effects that just suddenly happened to these observatories. And I have to wonder out loud how many observatories are not going to get built now because they can't really, especially surveys that can't really cope with that kind of failure rate or that kind of contamination level. So they may not even get built at all. I mean, I'm just thinking out loud about that, but I wonder. But the key takeaway here is that 30 to 50% of the it says here up to 30% of the exposures would be lost during the first and last hours of the night. It just says they're going to be lost. And almost 50% of the twilight exposures would be contaminated in wide field surveys like LSST. So is that acceptable? Is that worth the price that we're paying? And this isn't trying to say SpaceX needs to build anti-reflective coatings, although they're talking with astronomers about whether that would help them. But already, what are we saying? 300 are already up there. Another 60 are going up next week. So, and every 2 weeks thereafter, we're going to just keep having more and more and more satellites go up. So, is this a price we're going to pay? And finally, one more thing I want to comment on is the FCC. Who the hell gave the FCC the night sky? How come they're in charge of what can go up there? Now, I get that these are communication satellites and that they're regulated by the Federal Communications Commission and that they have to get a license to operate a transmitter like anybody on Earth has to do in the United States anyway. You have to get permission to broadcast over a certain frequency at a certain power. You have to have a license to do that. Okay, I get that. They have to have a license to transmit from their satellites. But why are they the only governing body here that says whether satellites can be launched? What does that have to do with the satellites themselves being placed in orbit and where they go? The mission requirements are dictating where the satellites have to go to do their job properly, between about 500 kilometers up in the sky, and they're going to be in various heights and various bands all over the Earth. So that's what determines where they go. But the FCC doesn't have, is that their domain? Do they get to pick? Well, because this is a communication satellite, suddenly we can give permission what can go where. I just feel like there needs to be more input besides the FCC. The FCC has not proven itself as a very great regulatory body, in my opinion. I mean, all we have to do is look at what they did with net neutrality to discover that they're very much friendly to corporations and what they want to do, and not so much anything else. So I just want to put that out there. I don't get that. I don't understand why who gave the FCC the night sky. I just don't know. All right. So I'm ready to read your comments. Now let's talk about some of this stuff. I'm sorry, guys. If you are on, let me see if anybody is on the Discord. No, nobody's on the public voice channel, so I won't put my headphones on. Interesting stuff, though. Now, reminder that the American Astronomical Society is doing a study too. And we'll see how this compares. Nothing about this seems wrong to me. They did make some simplifying assumptions about the number of satellites, but they just said, you know what, who cares who does it? Let's assume there's going to be 26,000 satellites up there at altitudes where these kinds of, like 500 or so kilometers would need to be. These low Earth orbits is what they call them. So, yeah, really, Land of the Celts. It's funny. That's a good idea. Well, you got to wonder, don't you? Yes, that's right, Larry. LSST is losing big time. And so I don't know. I mean, this is like, I'm torn. I've told you this before. On the one hand, I really want this internet. I want this service. I would pay for it. I would be a customer of this. It's just that I don't know I just don't want it to come at the expense of the night sky. As I have said so many times in these hangouts and in my videos, our night skies are disappearing, and we're not going to ever, ever, ever get them back. Light pollution is never going to get better. Suddenly, we're not going to just be able to go, oh, there's the Milky Way from downtown anywhere, right? You're not going to be able to see it. It's just never going to happen. And yes, there will always be pockets on the Earth where the skies will be dark and relatively pristine, and we'll be able to enjoy them. But we're going to have to really work at getting at them, and it's not going to be available to everyone. Not everybody's going to be able to enjoy this. Some people will never be able to see them. So it's tragic. It's sad. It's too late. I'm not saying let's do anything about it. The International Dark Sky Association, God bless them, I think they're doing what they can, but it's a lost cause. All they can do is try and say, look, be more informed about what light fixtures you put up in your city. Be aware of the effect that what you're about to do with this car dealership is going to really impact what we can see in the sky. And they're raising awareness in that way, and it's really good, but it's a losing battle. It ain't coming back. Our dark skies are gone. So, and here's another thing, right? Just one more layer of bullshit that we've got to put on top of this other stuff. So I'm torn. I really am. I don't know what to think of this. Okay, so I'm a star boy. Well, VR headsets that shows Milky Way and reduces light. Yeah, and there's also telescopes out there. We talked about them last week that try and mitigate the effects of light pollution on our ability to observe, and I think they're worth doing. Yeah, way to go. Yeah, that's right, Asteroid Hunters. I mean, unless you can give me property on the moon that I can set up our telescope for observations, then I'm good with it. Sure. Yeah, man. Give us some observing time on the moon, man. That'd be great. So I'm trying to see. LSST is now. Oh, you're right. I'm sorry, Adam. I should have pointed that out. And by the way, hi. It's good to see you again, Adam. LSST is called the Vera Rubin Observatory. It's no longer the LSST. I'm sorry. I've been thinking about it that way for so many years. It was so hard also for me to change from the Advanced Technology Solar Telescope, which was the ATST, to the what are they calling it now? The Daniel it's called DKIST now. Daniel, I forget his name, something solar telescope. So it's when they name it after somebody, I suddenly, the James Webb Space Telescope used to be called NGST. It was called the Next Generation Space Telescope. And of course, LUVOIR, if that gets built, that's going to be called after some guy too. Maybe me. I'm going to put my name in the Tony Darnell Space Telescope. TDSD. Come on, man. That sounds good. TDST. You want it. You want it. It'll be cool. The Tony Darnell Space Telescope. I want one. I'll take two. So, Civilian Space Agency. Musk is a self-made prodigy. Started in his youth. Great guy too. Met him a few times. Yeah, I don't got to comment. I hope this doesn't come across as a complaint about Elon Musk, the person. I get that he's got a really strong following of fans, and that he's got a cult of personality that rivals Neil deGrasse Tyson, Donald Trump, Bill Nye. All of these guys, they have their posse, right? So. I don't have any interest in pissing them off. But at the same time, these billionaires, of the space billionaires that are out there, Elon Musk, Jeff Bezos, Branson, why am I drawing a blank on his first name? Richard Branson, and even Paul Allen, to a lesser extent, although he's gone now. These billionaires all came together to do something for space and exploration. And it's one area where you can spend hundreds of billions of your own money, which they have, and actually be able to spend it on stuff. I mean, these guys have so much money that no one person can realistically spend it all on just themselves or their families or anybody else. I mean, so yeah, spend it on space. If I had $100 billion or whatever it is Jeff Bezos has, hell yeah, man, I'd start my own space program in addition to a lot of other things. I'd give most of it away, like a lot of people do. But I got nothing but respect for what he's doing. And like I said, I would be a customer of Starlink. I think depends on how good the service is. But I'm not talking about Elon Musk personally. So civilian space agency, don't think I'm busting on him, because I'm not. But this is a conversation, and I think we should talk about this. These are things we should talk about. I'm scrolling back up through the chat here. Okay, there's some stuff here on apartheid. I'm not going to comment on that. What are the odds of collision when I decide to escape? That's from Z Black Rider. Yeah, that's a good one. So let's see. What did I just see here? I agree. What's the limit? 1 or 2 million satellites? Yeah, I mean, okay. So you're right. Who's gonna? I don't know. What the limit on something like that would be. Then there's some political stuff in here. So okay, 1 million satellites would be a lot. They will be unlit. Ming Lord, they will be unlit most of the time and most of the year. Low albedo coatings hopefully will help. Well, Ming Lord, I hope this was early in the chat, so I hope as the hangout progressed, you sort of saw that we're talking a couple hundred satellites at any given time, and the biggest danger of them that are going to be up in the range that observatories look. That's the area from straight overhead to about 60 degrees above the horizon. That's where most astronomy is done, and so anything that's above that circle won't even be illuminated, except for when the sun is coming, either rising or setting, and does this. Remember this geometry here? Here's another. I didn't show you this. Schematic of the same thing, right? So I found this one less useful, but the observatory is at the top, and then you see the little satellite up there, and you can see wherever it's lit up, you see the sun in the lower in the lower right, or the right side of the picture, and it would be shining up and reflecting all the satellites. So where they're brightest in this schematic is where they would be most a problem to the observatory. So you're absolutely right. They won't always be a problem, and the time when they are a problem is in the twilight hours. So or in the of morning and evening twilight. So you're right. I mean, that is it. Except and most of this is fine with me. Most of this, I don't care. I think it could be dealt with by astronomers. It's that 30 to 50% part of these surveys that I find most upsetting. These surveys are, I don't think I can make you appreciate, maybe you do, just how important these surveys are. To look at large areas of the sky over and over and over again provides information on so many things that's going on in the universe. Closer to home with the Earth, we can see near-Earth objects easier. We can catalog more asteroids. We can certainly discover more comets and transient events like that. But it also helps us to capture supernovae and to characterize galaxy clusters all over, on the large scale structure of the universe. So there's lots of good science that can be done from a survey, and to have 30 to 50% of your twilight observations trashed, this thing says up to 30% of the exposures would be lost during the first and last hours of the night. That's a pretty heavy statement. And then almost 50% of the twilight exposures would be contaminated. That doesn't mean they're not usable. So, and you can remove that contamination, but it comes at the expense of precision, which is one of the reasons you're doing this in the first place, and accuracy of the data itself. You've got to remove the satellite trails, and then without removing the signal that you're trying to get, which is very problematic if you've just got one really long exposure image. So anyway, so there is that. Okay, so let's see. This will make it. Asteroid Hunters is saying this will make it tougher to find new NEOs with all these things flying around. There are times when we flag a new object only to find out it's a satellite. You should understand that Asteroid Hunters is running. He runs a telescope as often as it's clear to look at wide areas of the sky, confirming orbits of near Earth objects of the satellite of the I think it's the Atlas database you use. Anyway, he's looking along with his son at these near Earth objects and making sure they provide more orbital data to all the NEOs that are out there. NEO means near Earth object, and a PHA is a potentially hazardous asteroid. These are all things that are being looked at by satellites like WISE and NEOWISE that NASA operates. These are wide field instruments that look at the entire sky. But the Vera Rubin telescope will also provide a lot of data on that as well. So he is in a unique position to talk about this because he looks for these asteroids, and in some cases he also does work with the test data on exoplanets. So yeah, that's right. So good comment. Thanks for that, Alex. Or I'm sorry, Mike. So let's see. Hey, Alex Reinders, it's good to see you again, man. I'm glad you're back. God, it's like Kevin, the old friend's back, man. I'm glad you guys are here. Really am. Mike, hey, it's good to see Mike. I'm sorry, I'm caught back up. I caught back up on the chat here, so I was scrolling back up because I wasn't looking at it while I was doing all that talking. Land of the Celts, don't they get upset when you criticize their cult leader? The car in space was a great scientific achievement. Listen, man. Yeah, I know. It's weird. But that's the times we live in. You know, personality. You see it on YouTube here all the time. In fact, I was victim of it just last week. I had a cult leader who had his audience come over and bomb my chat just last week when we talked about the EV scope. So it's the times we live in. People have. I fought this so hard. I just am so reluctant to get internet famous. I don't want it, and so. There have been times in my YouTube career where things started to take off a little bit and it got really kind of scary. So I backed off, and I like it where I'm at. You know, a few thousand people watch my videos. That's all right. You know, and I'm never going to get rich doing this, and I'm never going to make really any money at all at this. But it's an educational thing I like to do, and I most definitely don't want to be the leader of some cult. And I say cult in the sense of the cult of personality. Okay, because that's the time we live in. We live in a time now. Well, I guess we've always been this way, but now it's easier to find a personality, someone that you love, you enjoy listening to, consuming their content, and then just thinking that they are the bomb. So much so that you become a zealot in their thing. And YouTube and Twitch and all of the social media platforms, Facebook, they all encourage that. They want you. Every YouTube advice I've ever gotten from the YouTube people, and I've had a couple of counselors and stuff throughout my career here where hi, I'm your YouTube representative. You want to talk about how to grow your channel? The one thing they always talk about is building a community, which is a code for, I think, making a cult, because it gets unhealthy after a while, and I've seen it. I've been the victim of it, and so it's like. I understand where they're coming from. They love Elon Musk. They think he's the best thing since sliced bread, and he is doing good things for space exploration. But he's not the altruistic, walk on water guy that everybody thinks he is. And it's the same with, the president. It's the same with, the big science communicators that are out there that everybody loves to idolize. I don't know, man. Is it healthy? Do you think that's healthy? It seems unhealthy to me. The people who are the subject of it, I'm sure love it because they're able to make a lot of money at it, or they can monetize that rabid client base they've got. But I don't know, man. It's the times we live in. It's just the way it is. I don't see anybody worshiping Jeff Bezos though, the way they worship Elon Musk. Have you noticed that? No one seems to be like being a Bezos bro. You see a lot of Musk bros, but you don't see any Bezos bros. I guess he's just not there yet. I mean, he's more buff than Elon Musk. You've seen him. The guy works out. He's like, so it's like, I don't know. Why aren't you like, following Jeff Bezos around? I'm a bigger fan of him than I am Elon Musk, if you want to be, if truth be told, if I had to pick a space billionaire, I'm picking Jeff Bezos because I like his approach better. I think it makes more sense to space exploration. What he wants to do is he wants to build the infrastructure first. And that makes sense coming from a guy who owns Amazon, right? He could not have existed. And he makes the point, rightfully so, that Amazon could never have grown or even existed at all had it not been for infrastructure already in place. Notably, the United States Postal Service, UPS, and FedEx, right? They were crucial to him being able to do what he did. He didn't invent those things, but he certainly used it. Sorry, I'm getting distracted by the chat. So so he takes the fact that he needed that infrastructure to build Amazon into his approach to space exploration. He says we need an infrastructure first. And he wants to be that infrastructure. He knows what he's talking about also because of AWS. If anybody knows anything about programming computers, you know about AWS because Amazon Web Services is the cloud. And nobody comes close, right? He built an infrastructure for the internet that is vital and now nobody can live without. And so imagine the same kind of thing for space. One of the reasons I'm a big fan of the Lunar Gateway is I think that's part of that infrastructure. I think that once you have something in orbit around the moon, you can use that platform to do other things, like go into the moon easily back and forth, go to Earth back and forth easier than if you went all the way to Mars straight there a couple years, and then you had to come all the way back from Mars a couple years. You want that. Wouldn't it be nice if there were way stations or some kind of way that you could make that easier and less expensive? And that's sort of the approach that Jeff Bezos is using with Blue Origin. So if you're going to put my feet to a fire and make me pick a space billionaire, he's my guy. I'm picking him. Okay. As a Bond villain. Look, I can do this. I can do my eyebrow up there. So, am I doing it? I can't see because I'm looking at the camera. He's not a bookseller. Are you serious, Peter Q? Knock it off. He's not he stopped selling. That's not all he sold. What was that? That was like 1998. He sold books, right? So, all right, Ming Lord, I'll take you up on that. Yeah. Joe or Joss, do you think space-based telescopes will be used more when the Starlink net is used at large? Yeah. So my good friend Jeff Kuhn, who works at the Planets Foundation, he's also part of the DKIST telescope I was telling you about earlier, makes a really good point about this. Space telescopes are extremely expensive, and they tend to be for their aperture way not worth the money for what you get out of it. I disagree with him on this, but this is the point he makes. So ground-based telescopes will always be a better value, and then you'll be able to do more science with them over time than you would with a given space telescope for the money. Okay, so one of the things he wants to do is spend $100 million or so on an ELF Exolife Finder telescope. This is a special purpose-built telescope that has an off-axis diameter or has off-axis primaries in a ring. Look up Planets Foundation and you'll see what I'm talking about. It's really a cool idea, and it's dedicated to just finding life in the universe because that telescope will have the scientific capabilities of imaging and resolving planetary surfaces. Okay, and that is what he feels we have to do to find life in the universe, and I think he's right. That is the right approach. A space telescope, on the other hand, let's look at JWST. $9 billion it ended up costing. Yeah, it's bigger than Hubble, and it's still going to have its limitations. It's already oversubscribed. People are waiting in line to use it, and it will be great. LUVOIR will be even greater, or the Carl Sagan Space Telescope, if they manage to build that. It's kind of a pared down version of LUVOIR. I did a video on all this stuff, so check out my videos on this. The Carl Sagan Space Telescope would be an ultimate kind of platform to look at really everything in the universe, but that's just one telescope, and it's going to cost billions and billions of dollars. I mean, on order of 15 billion for LUVOIR, right? So, it's going to be a lot of money. All right. Is a telescope based, this is from Anthroparian. Is a telescope on the moon based, space based, or good question. I'm going to go with moon based. I think it's moon based. It's lunar based. But you're right. And Andy Cowley, that's right. We need a telescope on the moon. And again, if you start with the Lunar Gateway, which everybody seems to be crapping on because Robert Zubrin doesn't like it, and that's another personality that people get really finicky about when you start criticizing him. Robert Zubrin says, oh, it's all about Mars. Go to Mars. This stuff about going to the moon is stupid. It's not stupid. And it needs to get done. I think at some point, what are you going to, you spend all this money, time, and energy going to the Mars. You're going to the Mars? I ain't going to the Mars. That's too scary, the Mars. The moon, I'll go to the moon, but not the Mars. But going to the moon makes a lot of sense in so many ways. It's more value for your money. You get platforms closer to Earth. We get experience being outside of the Earth's magnetosphere, something we do not have. And it would be nice to have all that stuff, that experience close to home. Agreed. It's going to take decades longer for us to get to places like the Mars. Again, like the Mars. But, I think it's got to happen. I think you need to do it. So, all right. Did I say go to Mars is stupid? He means going to the moon is stupid. All right. Yes, we do, Peter Q. That's correct. All right, guys. So I'm done ranting and raving, I think. It's been about an hour. Let's see. Azure isn't that far behind. Yeah, that's true. You guys are funny with the Bond villain thing. All right, so let's see. Bezos, this is from Anthroparian. Bezos fished some of the J-1 engines from the Apollo missions off the ocean floor. Did he? I did not know that. Tony as a cult leader. I can't see him as the next Charles Manson. Everyone, I want you to listen. Listen to me. I want you to go outside your door right now, even with the virus. The virus is not going to affect you, okay? I want you to go out and buy a telescope. See how many people do that. That was a joke, by the way. Yeah, I'm sick and tired. I get, this COVID-19 thing is really starting to affect a lot of lives, isn't it? That's why we're here. That's why we are here in virtual land. We don't have to worry about. We can wash our hands of the whole thing. All right. Well, I guess that's it. But most of the chat, I think I've responded to most of it. The TMT and the 39 meter is now in danger. Yes, the 30 meter telescope. Well, I don't know if it's in danger. It's certainly in danger at Mauna Kea. The 30 meter telescope, for those of you who don't know, is a giant new observatory they're trying to build on the summit of Mauna Kea. However, there are concerns from the local Hawaiian culture about building another observatory on their sacred site. Now, I happen to think that not only do I respect that, but I also think this is they're using the 30 meter telescope as a lens through which they can make people aware of the fact that their culture has been hijacked by a lot of stuff from the United States, where tourism and becoming a state notwithstanding. I mean, a lot of people really think that the Hawaiian culture was damaged when that happened. And so this is an opportunity for them to raise awareness of what's happened to them as a culture. I actually support that, okay? And I'm okay with a 30 meter telescope not getting built on Mauna Kea in respect for that. I'm okay with it because I also think they could build it, maybe at a little extra money, on the Canary Islands. So if they go to the Canary Islands, which currently, by the way, houses the largest telescope in the world, ground-based telescope the largest telescope in the world is currently there. I think that's a good place to build it. Okay, it's a good location, and they're willing to have it being built there. Same is true with places in Chile. Chile as a country has been very friendly to astronomy as an industry because they realize that this is a way to help their economy as well. One thing that I noticed about being in Hawaii, I've been to Mauna Kea many times. I used to help operate a solar observatory at Mauna Loa, and when we went, I would go there. I've been there 5 times to work on various things there. And every time I went, I was struck by how the big island of Hawaii, the University of Hawaii in particular, was a big part of the culture there. And to have a place where you visit and astronomy as an industry, I don't know. I felt it was kind of cool. All right. The seeing is great in the Canary Islands. It's some of the best in the world. It's right off the west coast of Africa. I think it's off the coast of Spain, actually. And it is it's got it's an area of the world where the weather is such that, just like Mauna Kea, where the clouds tend to form low below where the peaks are, and above those peaks, it's you get like, I don't know, at least 300 cloudless nights a year, maybe even more. And it also has the characteristic of being very dry. There's not a lot of water vapor up there, and that's huge for people doing infrared astronomy, and that's why Mauna Kea is so important as a site, because it's also very dry, and infrared astronomy can be done there. Water vapor blocks out a lot of infrared wavelengths, and so you want as dry a spot as possible so it doesn't absorb the infrared radiation you're trying to look at. So you want high and dry, the Andes Mountains, high and dry. Same with Mauna Kea and the Canary Islands. Excuse me. I don't know. I've never been, Neil, to the Canary Islands. I need to go. I need to take a trip at some point. I'd love to go there. I have an ex-colleague of mine works there, and I had him on a hangout recently about some exoplanet stuff he was doing, and I'm drawing a blank on his name. Anyway, I met him at the High Altitude Observatory, and we've had a hangout together, and I am drawing a blank on his name, so I just embarrassed myself. Okay. All right, guys. Well, that is it. I'm going to go ahead and stop now. I hope you guys got something out of this hangout. I want to thank you for joining me. This is a weekly thing, so I'll see you next Thursday. Next Thursday, I don't know what we're going to talk about yet. I only decided this morning what this topic was going to be about. If you would like, or if you know somebody who would like to benefit from being in a hangout like this where we can talk with everybody, please reach out to me on Discord, and you can also email me via my website. If you go to deepastronomy.com and you just go contact, you can say, look, man, invite this guy to a hangout. He might go. And so that would be a way where we could work together and get some guests on that we'd like to see. I don't know of any good observatories in Asia. I'm sorry, I don't know of any of those. All right, John. Well, thank you. Appreciate it, guys. Son, the Hawaiian Islands are crowded. Yeah, but Hawaii's not so bad. Hawaii, of all the islands, Maui is pretty bad. That's where they built Deakist. But Hawaii's not so bad, and not a lot of people go. If you stay away from Kona, which is where all the tourists go, the Hilo side is really kind of nice. It's cloudy a lot because it's the leeward side of the island, but I don't know. I kind of like this. It's got black sand beaches. There's not a lot of people there. There's a lot more locals there, a lot more Hawaiians there, which makes, to me, I find as a plus. I like that. And I don't know, local food and all kinds of cool stuff like that. So I recommend the Big Island. It's really kind of cool. I wouldn't go to Oahu. God, no, that would be my nightmare. Okay. I should never stop quitting going to the Mars. First to the moon, but then for sure to the Mars. And that's right. Let us go to the Mars, everyone. All right. On that note, I will leave you with that. Thank you all so much for watching. My name is Tony Darnell from deepastronomy.space. Thank you for watching. I should have said that first. And as always, keep looking up.